Hi students, good morning. I hope you are doing great. My name is Samuel Chukwu Emeka, as usual. In this video, we shall discuss the mathematics of finance. So let's get to my website. It is highly recommended that you view the previous videos in the playlist prior to viewing this video. So the video that we are about to do now will be in this playlist and other related playlists as well. So we get to notes, and this will be Module 7 Homework Study Guide. I want to say this, the Module 8 exam will cover both the Module 7 homework and the Module 8 homework. So the exams cover the homework and the previous homework. In this video, we shall convert percentages to decimals and decimals to percentages. Then we shall solve simple interest problems, compound interest problems, continuous compound interest problems, and APY problems. APY means annual percentage yield. Please, it is highly recommended that you view the prerequisites. These are the prerequisites. They are video playlists. They are not just one video. It is recommended that you view the prerequisites prior to viewing this video. And the formulas that we are going to make use of will be here. I'm gonna make use of the compound interest formula and the continuous compound interest formula and the APY formula. Financial mathematics is a very important math unit for business majors, finance majors, economics majors, mathematics majors, and so on and so forth. So let's get started with the questions. Convert 2% to decimal. Percent means out of 100. Let me pull up my calculator. I will show you some ways to do some calculators here. And when you pull up the calculator, initially it is like this, the standard. You click on view, you change it to scientific. So this means 2 divided by 100, and that gives you 0.02. Then convert 0.41 to percent. That means you multiply by 100, and that will be 41%. Number 3, find the principal if the interest is $72, the interest rate is 8%, and the time is 6 months. So if you look at this, the videos and the notes, you have to convert. This is an example here, because I also did examples. This compound interest. This is a simple interest. So let's pull up simple interest. So some of these examples I have already done here, and I have done this in the videos. And where would you find this in the videos? It's right here. You click on videos and you go to mathematics of finance. There you go. Mathematics of finance. So these questions here, this video is this note right here. Okay, this video is this note right here. So you have the notes and the videos. You have a lot of resources for your success. So the questions that we will cover here, we have done some of it right here. So by the time you finish these prerequisites, this will be a piece of cake for you. So you have to solve for P because they are asking you to find a principal. Of course, this is the simple interest formula. And when you do that, you now have 1800. I will show you how to do it. You just have to do it step by step. You make sure you convert the time to year. The time is always in year. I probably wrote the formula here as well. Yeah, P times R times T. So the principal is in the currency. Dollars for the United States, Naira for Nigeria, any currency for the country that you are in. The R is the interest rate, annual interest rate, or interest rate per annum, per year, annual, annum means year, yearly. It is usually expressed as a percent, but you have to convert it to decimal. Then the time is in years. Okay. The interest also is in the currency. The interest. So I have talked interest or simple interest is in the currency. So we have, and I have done this in previous videos. So this is like a repeat of what I'm doing. So please, the prerequisites will really be enough. But if you want to test your skills, you now solve the questions here. So how are you going to do this? You first of all do a 0.08 times 0.5. 0.08 times 0.5. And it gives you this, 0.04. Let's say that you didn't want to write this. Okay. If this was a big number. If this was a big number, just store it in memory. Press M+ to put it in the memory of the calculator. Then you now do 72 divided by recall memory recall, and that will give you 1800. So that's the way you do it. Question 4. You make sure that the time you convert 180 days to a year. In this case, the question tells you to assume a 360-day year. So don't use 365. Whatever they tell you to use, you have to use. So you solve for R. Now, for some of you that will say, okay, how do I solve for R? How do you know, Mr. C? How do you know that R is I over P times T? That goes to what? Literal equations. Literal equations right here. You need to view my video on literal equations. Solving for a variable. That is the algebra. Mathematics, algebra, literal equations. Right here, literal equations. Solving for a variable. So you need to view these two videos and you should understand why I solve for R. Why I solve for R to give me this. Okay. Number 5 is find the time. And we use the same principle we solve for T. Question 6. How much interest will you have to pay for a credit card balance of $810 that is 1 month overdue if a 23% annual rate is charged? Yeah. Like I said, even in the prerequisite, I did this type of question. In the prerequisite, yeah, that is like this one. Question 7 here. So you solve for I. You saw for I, you have to convert this to 1 month to 1 out of 12. Okay, let me say this. This is important. When you know that you will have a repeating decimal, or if you have if you will not have an exact decimal. An exact decimal is something like 0.23 or a terminating decimal. If you will not have a terminating decimal, then it is better you do this as fraction. Some of you might try to do 1 divided by 12. It will give you a non-terminating decimal. Is a repeating decimal. So I will suggest to you that if you know that you will have a repeating decimal or a non-terminating decimal, if you will not have an exact decimal, do it as fraction like I did it. Now, if you must do this as decimal, let me remove this MC, cancel memory. Now, if you must do this as decimal, okay, see what you're gonna do. Just use everything like this. Then you now do times 0.23 and then times 810 to give you that. Yeah. Because why am I saying this? If you approximate, then you might not get the answer right. That is why I'm saying it. 1 divided by 12 is 0.083. Okay. Let's say some people approximated. Some cases you might get it right, some cases you might not. Let's say some people approximated to 2 decimal places. Now, but one thing is for sure, whenever you are dealing with money, you do not approximate until the final answer. We have mentioned it in the previous videos. Do not approximate until the final answer. So, assuming you approximate to this 0.08, then you do times 0.23 times 810. So you see, you get a different answer and you get it wrong. So do not approximate. If you will know that any intermediate calculations will not give you an exact decimal, then don't approximate. Now, some other people might approximate to 0.083 times 0.23 times 810. Okay, it gives you different answer too. So how long are you going to approximate, folks? How long? I mean, will you approximate 0.08333? I mean, the more you approximate, the more the number of decimal places you approximate, the more accurate your answer will be. But Mr. C is advising you, when you will have any intermediate calculations that will not give you an exact decimal, just do it as fraction, period. Okay, just do 810 times 0.23 equal to, you do this one first, equal to, then you now do divided by 12 equal to now give you that. Or if you must use the decimal, then use everything, use every single thing, everything. Do you understand me? Okay, if you don't understand me, just ask questions, okay? The next one is the same. Well, the next one, they now give us the amount. So I gave you 2 formulas here on simple interest. You have the first one, interest is principal times rate times time. And the second one is the amount. Amount is principal plus interest. And I have explained all these concepts. Okay, I explained it in the video. So view the videos to understand these concepts. So this is the formula we are going to use here. And this formula is very important. So that is the same thing we do here. We'll use here. Of course, the interest rate percent, you have to always convert to decimal. The time, you always have to, if they give it to you in any unit other than years, you have to convert it to years. So this is the amount, and then but you have to solve for t. How do you solve for t? Literal equations. This will teach you how to solve for t. Okay. Now, why didn't I mention it as prerequisite? Because the prerequisite will tell you, when you go to the prerequisite, like simple interest, you see it right here that literal equations is a prerequisite. So you see that these are interconnected topics. You need to master a previous topic prior to the next topic. And I'm here to help you out. So when you have done it and you still don't get it, you ask me. That is when I come in. So when you solve for t, you have this. This is I use this division because this is an exact decimal, 1.3. So it's an exact decimal. So I just divided it. If not, I would have solved it as fraction. I probably did that in one of these videos, solving as fractions. It might be a video on compound interest. Something I had to solve as fractions just to make sure, just because it is not an exact decimal. Question 8, we solve for r. We use the same formula, but we solve for r. You make sure that this time for 6 months, you convert it to years. Now, 6 divided by 12 is 0.5. So that is an exact decimal. So you can use it. But assuming you do not have 0.5, then you have to use the fraction. Or if you must use the decimal, use all of it. All of it. Okay? So when you do that, you get a 6.5% here. Question 9. Use the compound interest formula to find the future value A. So this now back to compound interest. Compound interest, I gave you 2 formulas here when I did it here. And it's the same thing. It's the similar questions also. So this is the main compound interest formula right here. But you can also have it this way. This is another formula here. This is another formula. This is another formula. So you take note of these 4 formulas. But whenever you are asked for compound interest formula, this is the formula right here. So, but they want us to use this formula here. And that is this one here. Amount, A is the amount of future value. P is the principal or present value. I is the annual interest rate per period. And N is the total number of compounding periods. I explained all these in the videos. Videos on mathematics of finance. Here. I explained it here. So when you do that, you get this. Now, let me explain this. I want to say something here. You have to do this PEMDAS. PEMDAS. Please excuse my dear unsalary. Parentheses, exponents, multiplication, division from left to right, addition, subtraction from left to right. We do parentheses. Okay, when you plug in, when you substitute. I said plug in. Plug in is the common word, but substitute is the mathematics language, mathematics word, substitute. When you substitute for these variables, okay, substitute the values for these variables. You do this first. You see the way I'm doing it. These steps are important because I would have just, if I had a TI Inspire or even TI 84 or TI 84 Plus, I can just put in this right away, like this, provided I put it in right, and it will give me this. But everybody does not have a TI 84 or TI Inspire. So I'm going to, you do step by step. You do this first. You do 1 plus 0.054. It gives you this 1.054, and you press x raised to power y. Okay, 23 equal to, each one you do equal to. That is the way to do it. Don't just come and do it and do times 1500. No, you have to do it, the calculations, step by step. Each one you do equal to that. Then times 1500 equal to. So do you see the way I do it? You see, I don't skip these steps, because if you skip these steps, you might make mistake. You might make mistake. Question 10, we have to solve for P. So, you do that. In this case, you can use your memory. You can use the memory function. If you don't want to write out everything, okay? If you have 1.05, although I didn't use this calculator, I used my own calculator when I did this, but I'm sure that will be the same answer. If you have 1.05 x raised to power 102, so you have this. You see, it's too much. Now, my calculator will not write all these digits. But guess what? If you are using the calculator on the computer, you don't need to write out all these. If you know how to use the memory, I will show you again. Just put this in the memory of the calculator, and then you do 22,900 divided by recall memory, and that will be this 157.95, $157.95. If you don't know how to use the memory, that's fine. Just write out everything. If you ask me, okay, why didn't I write out everything? Well, I did not use this calculator when I was doing these notes. I did not. I used my own calculator, Casio, that I had. And this was the entire thing I had. So, but if I had used this calculator, yes, I'll write out everything. I will. Otherwise, you just use the memory function in your calculator, in the calculator on the computer. Question 11, find I. I is annual interest rate per period, right? Annual interest rate per period, that is I. R over M. So find I, they gave you the R of 5%. You have to convert it to decimal, 0.05. Monthly, compounded monthly, good. In this one, if they say compounded monthly, compounded weekly, compounded daily, I did it here. See? Compounded annually, M is 1. Compounded semi-annually, M is 2. That means 2 times per year. Compounded weekly, M is 52. That means 52 times per year. So compounded monthly is 12. So we're going to use M as 12. And then you just, you just divide it. And of course, you have to convert to percent. And this means 0.417% per month. I want to say this. They say round to the nearest thousand as needed. So this means that 1,000 means 3 decimal places. There you go. Question 12, they ask you to find R for 1.5% per quarter. So this is the I. Okay. Remember that I is this per month. So in this case, I is 1.5% per quarter. And per quarter means that M is 4. Quarterly. Your GDP quarterly growth. Do you listen to the news? In the news, NPR, National Public Radio, they give the business news, GDP quarterly growth. Okay. So you do this. When you do this, you find that you solve for R, and we see that R is 6%. Question 13. If $2,000 is invested at a 4% compounded quarterly, what is the amount after 6 years? So in this case, we have to use this compound interest formula right here. This one. This is what we will use here. And I have explained all these in this what? Video. So if you use that, let me show you with calculator how you can do this. You just do it step by step. You do the parentheses first, then you do exponents before you do the multiplication. So here you do a 0.04 divided by 4, and that gives you 0.01. If you just do this the way I am writing it out in these steps, you will not get it wrong. Trust me, you will not. You've got to do it, you see how I'm doing it step by step. Okay, then the next one is +1 equal to, each one you do equal to, and then you do x raised to power y. Okay, to put x, this 1.01 raised to exponent 24 equal to, and then you now do times 2,000 equal to. So this is what you have, $2,539.47. That is what you will have. Question 14. Agnes received an $8,000 gift from her grandparents towards a college education. How much would the $8,000 be worth in 17 years if it is invested at 8% compounded quarterly? So in this case, they're asking us how much it will be worth. That is the amount. They're asking us for the amount. So you do the same thing, and this is how much it will be worth. Question 16. Use the continuous compound interest formula to find A if the principal is $4,000, R is 4.64%, which of course you convert the percent to decimal to give you 0.0464, and the time is 7 years. Round to 2 decimal places as needed. Okay, these answers are supposed to be in red. I know I did it. I don't know why it is appearing like this. Let me refresh this. Oh, I would have checked for the slide if I refreshed it. You can easily jump to the slide like this. We were working on question 14, I guess. So question 14 right here. Oh, that's not question 14. We are going to question 14. Okay, there you go here. Oh, it's still not in red. All right, but don't worry, I will have it in red color. Oh, the answers are in red. Yeah, the answers are in red. So in this case, they are asking for continuous compound interest. So we use the formula here. You go to this, and I have done this here in this video here. What it means. So continuous compound interest formula will have we have this continuous compound interest formula. Of course, we see that E is the Euler number or Napier's constant. And I showed you how you can get the Euler number. I explained it in the video. Euler's number or Napier's constant. That is E. All right, so you do the same, you come here. You want to do it step by step. Let me cancel this memory and let me clear entries. You do this first, 0.0464 times 7. 0.0464 times 7 equal to, see that it gives you this. And then we have to do E exponent that. If you look at the calculator on your computer, we don't see any E. We do not. Right here, you don't see E, right? But the E is the inverse of ln. Just so press the inverse function here, inverse function, and then you now see this E. Okay, so you press this right away. E exponent that, it gives you 1.383. You see that? And then you now do times 4,000 equal to 5535.02. Because they want you to round to 2 decimal places as needed. So that gives you this. Question 16. Use the continuous compound interest formula to find P. In this case, we solve for P. You use the literal equations, and you do that, you get this. Question 17 is similar, but you solve for T. In this case, you solve for T. This is where we will introduce logarithms. Because whenever you have if you have E, you know, anything exponential, logarithms is the inverse of exponents, and exponents are the inverses of logarithms. So if you have logarithm and you want to isolate the variable, you just apply exponents. If you have exponents and you want to isolate the variable, you just apply logarithms to both sides. Please, folks, this is what you will need to view. Under continuous compound interest, I have this as logarithms right here, logarithms. And I also sent it as an announcement to you. So where is logarithms? Logarithms, I have put logarithms here, but you don't need to view all the videos. Mathematics, finite math. It's still, logarithms is an algebra. I mean, you probably did this in algebra, but you get to do it, use it in a finite math. Logarithms, logarithmic equations, and functions. So click on it. Just these 2 videos are important. These 2. Yeah, you don't need this 3 and 4, but these 2 are important to make you understand what we are doing. For solving for T, because T is raised as an exponent, so we have to introduce logarithms. In this case, we introduce log to base E, natural logarithms, or Napierian. We call it natural logarithms or Napierian logarithms. That is logarithm to base E. So when we introduce that, then we now have, it will isolate RT. Then we now solve for T. So please, if I start explaining logarithms here, the video will be more than 1 hour. So that's why I had this here. So if you look at it, then you will understand what I'm saying. And you can also view the video on continuous. If you don't want to view this, you can also view the video here. Mathematics of finance, continuous compound interest. Yeah. There's something I want to say here. Round to 2 decimal places as needed. Okay. If you get 2.50, it is correct. But somehow or another, MATLAB is stubborn and might not recognize it as an answer. So you just give them 2.5. Okay. You try it as 2.50 because they say 2.50 as needed, and you had 2.499999, you know, 2.4999996003. Of course, to 2 decimal places will be 2.50. But for some reason or another, Pearson MATLAB is stubborn, probably, to recognize it. Okay, just change it to 2.5, okay? I know that 2.50 is the actual correct thing. It is. Question 18. Agatha invested $5,000 at 4% compounded continuously. What is the amount after 8 years? So we use the continuous compound interest formula, and we got this. We also did an example like this here. Okay, that would be continuously finding A. Yeah, we did examples like that here. We did example like the previous one, and then we also did this is an example of the previous one, 4 and 5. The previous one we just did, and we also did an example here. So in these examples I did here, which is in this video, we solve for A, we solve for P, we solve for R, and we solve for T. Question 19. Ignatius wants to have $12,000 in the future. He invested some money in a bank that pays 4% compounded semi-annually. A. How much should he deposit 5 years from now? B. How much should he deposit 10 years from now? So this tells you that he wants to have 12,000 in the future. That means the future value, which is the amount. The amount is the future value. It is that amount is $12,000. So how much should he deposit 5 years from now, which is the present value or the principal? So you have to use the compound interest formula, but you have to solve for the principal. You have to solve for the principal. And when you do that, 5 years from now, 5 years from now means that T is 5. So you find the principal. And of course, semi-annually means that M is 2. Semi-annually means that M is 2. Okay. Then you solve for P for the question A. You get that. And then 10 years from now, you solve for P again for 10 years. You get that. Question 20. Compute the APY, annual percentage yield, for A, 11% compounded monthly, B, 9% compounded continuously. Please, for this A and B that we just did for question 19, it is right here. Compound interest is right here. I also did it here, an example like that. And it's also in this video where I really did it. Okay. Then the last but not the least, the APY, 11% compounded monthly, 9% compounded continuously. Round to 3 decimal places as needed. APY, this is the formula. We have 2 formulas for APY. This is the APY for compound interest, right here. And this is the APY for continuous compound interest, right here. So when you just have to change the rate to 11% is 0.11 and 9% is 0.09. Okay, and you have your answer. APY for 11% compounded monthly is 11.572%. APY for 9% compounded continuously is 9.417%. Now, some of you will ask me, what is APY? Right? That is why I have this video right here. APY. I explained what APY is. And I did similar problems here, you see. Also here. More problems here. Okay, folks. Thank you for listening. And this is the references. If you have any questions, please feel free to ask me. Thank you so much for listening, and I hope you do great in the test and the exams. Or, and you have a grade.